Hello, my name is Charles Martinez. Today is September 25th, 2021. Time is approximately 3:24 p.m. And this is my Circe 01 attempt C. And in this attempt, we'll be getting the LED to turn on and to blink. The kit originally called for a 10mm, but my kit only came with a 5mm, so I'll be attempting this with a 5mm. So the instructions and the parts used are going to vary just a little bit different. In this one, we're going to be having it to where the LED does come on for 1 second and off for 1 second repeatedly. It's going to be pretty much looping on, off, on, off. This one, it was the original code was created June 1st, 2005 by David Cortelis, based on original by H. Bearing the wiring of I/O board. So this is all their stuff there. It came with the original coding that we copied and paste. And in this code here, we'll be discussing integer LED. I'm going to go through the code, integer LED pin. So pretty much what we're doing is we're declaring a variable. Variable name is going to be LED pin equal to 13. So each time it calls LED pin, it will be knowing to recognize for pin 13. Of course, our void setup will just pretty much end that initial phase, and then it won't have to redo that anymore at any point. And then with pin mode, LED pin output, we're going to be verifying that there will be output to LED pin 13, which will be power, in this case 5V out to 13. The next part of the code, piece of the code, is going to be void loop, and we have our curly braces after our void loop. Our void loop pretty much indicates that we'll be looping indefinitely until the Arduino unit itself is powered off or turned off. So it'll continue doing pretty much the code in between the curly braces until the unit itself is powered off. And in the code, we have our first line reads digital write LED pin high, which pretty much means digital write. LED pin is the variable for pin 13, so it'll send an output to LED pin for high, indicating that it's on, and that it has power. So it sets the LED on pretty much. And then the next piece of code is going to be on code line 16 will be delay of 1,000, which will be approximately about a second. So we'll have a delay of a second. Digital write LED pin low will set the power to off pretty much. It gives it no power, so you'll have the LED turn off at that point, and then a delay of a second where after that, at this point, it turns to loop itself afterwards, and it's going to go back to high and then low and then high and then low. So let's go ahead and verify this code to make sure that our code is correct and that everything is legit. So we'll hit the verify up here. We'll get the little deal scrolling here, and we get our message here saying that everything was good. No errors are found, nothing red, so we're good. So then we'll go ahead and go to the upload, and then we need to explain this little guy here first, and this is the code we get when it's not connected, because I forgot to explain this, but let me explain this real quick. So in this little guy here, this is the Arduino kit. It's connected to the breadboard. I do have it on a baseboard where it's kind of tacked down. But let me go over the breadboard real quick. And here we have our positive connected to the 5V positive. And let me see if I can get you a better picture. Yeah, we got it connected to 5V power. And then the ground, the spot 2 little slots away, is connected to the green wire, which goes to our negative slot, which gives negative throughout this whole little deal here. And you can see where our resistor is going to connect our negative, and our negative is connected to pin 10. Our LED negative that has the long and the short. The long one is the positive, the short one is the negative. Our negative is connected into pin 10 in the breadboard here, which would be F10, I guess, if you follow those letters and numbers. F10 will be our negative, and F9 will be our positive, which will be getting our positive signal from our yellow wire here going into our pin 13, which is embedded in our code that says to turn pin 13 to a high or a low, or turn it on or off. And so that's our setup here in our Arduino and our breadboard, our LED. So if everything works properly, this light should blink on and off every 1 second until the Arduino is powered off. Okay, let's go ahead and plug it in now. We'll plug it in. It's on. And now we'll go ahead and upload again. Hit upload. We're gonna get the little code going, and then we get the deal, and then we get our send and receive just went off, and then we got our light blinking here. So looks like everything went good. We're on second on, second off, second on, second off. LED. This resistor here is a 220 ohms resistor, which the resistor resists the flow going through so that it's not getting full current, so it doesn't blow out your LED. It doesn't send too much power. It restricts the power going through it so that it's a lower current, so it's not getting too hot, and it doesn't overload and give out, burn out pretty much. So that is the whole explanation of our Arduino kit here. This was very fun and amazing. I did enjoy it, so please consider that. This is very fun. Thank you. Bye bye.